Welcome back, everyone. Today what we're going to do is we are going to review 3.1, 3.2, pretty much going over the basic derivative review. All right, so what that entails is finding tangent lines of slopes of points, using the power rule to solve derivatives, and understanding some slope and physics problems. Okay, so we're just going to touch on all that stuff and see where it takes us. Let's start with two questions we did a while ago. This is finding the tangent slope at the following points. Now, first question, f of x equals 1/2 x squared minus 3, and that happens to be at point 4, 5. So first thing we have to do is we have to find the tangent line, the equation of that, and then we can just plug in our x value from our point, which is 4, 5, and that will give us the actual tangent line slope at that point. So first thing here, we're going to use our formula, f of x plus delta x minus f of x over delta x, and that's going to be your slope. Now, first thing you have to do is find out what f of x plus delta x is and f of x. So, f of x is always just given to you. It's the equation that's given. That's pretty easy, okay? So whatever it tells you the equation is, f of x equals that because it says it. Now, f of x plus delta x. The way you solve that is you're going to take x plus delta x, and do you remember what to do? You plug it in for the x right here. So it's 1/2 x plus delta x, remember I just replaced the 2, squared. So now you're going to have to square that middle part. Now when you square something, you FOIL it. So pretty much it's x plus delta x times x plus delta x, which is x squared plus 2x delta x plus delta x squared. Now you're going to multiply it by 1/2. Remember you have to do the exponent before you do the multiplication. And then there's a subtraction of 3 in the end. So now I take the 1/2, I distribute it to each one of these three things. 1/2 x squared plus x delta x plus 1/2 delta x squared. And then don't forget your minus 3 in the end. A lot of people sometimes forget you have a little minus 3. All right? So we got our two pieces here, and we're just going to take these two guys now and plug them into this equation. This goes here, that goes there. So you have 1/2 x squared plus x delta x plus 1/2 delta x squared minus 3 minus 1/2 x squared minus 3 all over delta x. Okay? Because the limit is at delta x approaching 0, that's why I have to expand this and simplify it. Because if I just plug in 0 right away, I get an undefined answer. That means the limit doesn't exist. That's no good. So we have to kind of like simplify the limit. So now once you get here, usually whatever is in the f of x is going to be in here as well. Right? And it cancels out. Watch. 1/2 x squared minus 1/2 x squared. Cancels out. We have a -3 here. -3 minus -3. They cancel out. So it just leaves me with the two middle pieces, x delta x plus 1/2 delta x squared over delta x. Following still? Good. Now, I could take this and I could reduce this. I could take 1 delta x out, leave me with none. One of these two out, leave me with just 1 delta x here, and the bottom becomes a 1, okay, because it cancels out. This is the goal. The goal is to cancel out the delta x on bottom. So now you're left with x times 1, which is x, plus 1/2 delta x over 1, or just that. Now, because there's no delta x on bottom, my answer will not be undefined. I could plug in my 0 for delta x. So it becomes x plus 1/2 times 0, which just simply equals x. Now, that is my tangent line. Now to find the tangent slope, I take the x value right here, which is 4, and I plug it in. So when m is 4, my answer is 4. Right? If this was point like 7, 2, what would your answer be? 7. If this was point 2, 7, what would my answer be? 2. It would be whatever the x value is, okay? Because this is x, it'd be exactly what the x value is. If it was -7 a billion, your answer would be -7. Right? You got it? If it was 0, 12, the answer would be 0. It's just your x value. Now, let's move on to problem 2. Another easy problem right here. F of x is given. Plug that in. Now when you expand it the same way you expanded it here. X squared plus 2x delta x plus delta x squared plus 7. That was pretty easy. Plug these two into the equation. Once again, x squared minus x squared cancels out. 7 minus 7 cancels out. Leaving me with 2x delta x plus delta x squared over delta x. And as it always happens, as I tell you this, you're going to cancel out your delta x's. So you got 2x times 1 plus delta x over 1. So it's just 2x plus delta x. Delta x is approaching 0, so you plug it in. 2 times x plus 0. And your answer is going to be 2x. Right? Now, here's the key here. Once again, we're going to plug in our x. Our x here is 3. Okay, so when x is 3, it's going to be 2 times 3, so your answer would be 6. Okay, so that's your actual tangent line slope. This is your tangent line. You get half credit for each part. Now, say this was at point 4, 5. It would just be 2 times 4, which is 8. Right? Good. You got it before. You should remember how to do it again. Now, we're going to get into the easy part. These are derivatives. So, first one. What is the derivative of negative 8? Now we're going to take all the shortcut methods. So this is, that really quick was 3.1. This is 3.2. Derivative of a constant is always 0. So the derivative of negative 8 is 0. Now here we're going to have to use our power rule. N, which is our exponent, times x to the, whatever your exponent is, minus 1. And if there's a constant out front, you just multiply it by the constant in the end. So this becomes 6 times 5, x to the 5 minus 1, which is 4. And then you multiply the constants. 6 times 5 is 30x to the 4th. Right? Sometimes you have to rewrite these. You never want to have it on the denominator because you guys don't know the quotient rule yet. We'll learn that next week. What you do here, very simple. Anytime you have a number over something to a power, that power becomes negative. So this just becomes 2x to the negative 5. Same exact equation, just written differently. But now we can use our power rule. So you got 2 to the negative 5, x to the negative 5 minus 1 is negative 6. That gives you negative 10, x to the negative 6. All right. If you want to rewrite it, be my guest, you can make this negative 10 over x to the 6. Got it? Awesome. All right, finally problem 6. If you have a radical, rule for the radical. Slide over here so I'm not in your way. Whatever the radical is, whatever root you're taking, is denominator. Whatever power is under the radical is your numerator. So what would the 7th root of x to the 4th be? This would be x to the 4 over 7. And now you're going to use your rule again. 4/7 x to the 4/7 minus 1. Now 4 over 7 minus 1, in case you forgot your fractions, not that difficult, but I'll just give you a little hint. It'd be 4/7 minus 7 over 7, okay? Because you want the common denominator when you subtract fractions. 4 minus 7 is negative 3. So it'd be 4/7 x to the negative 7, negative 3/7. All right, if you want to put it back in this form, this would be 4/7. Since this is negative, it goes in the denominator, x to the 3, and it would be the 7th root of that. All right, either way, writing it is acceptable. All right, or you could do, it's better. Got it? All right, let's do some more. Trig. What is the derivative of cosine? Negative sine. All right, that should be given to you. So this is just 2 times negative sine x, which is negative 2 sine x. Number 8. Now this one's a little trickier. You're going to have to simplify and reduce this first. What is tangent? Tangent is sine over cosine. What's secant? Remember secant? 1 over cosine. So if I rewrite this, I get this as 3 sine over cosine divided by 1 over cosine. Now because I have a denominator of cosine for the numerator and a denominator of cosine for the denominator, I can actually cancel them both out. All right, what you'd really do is you'd really move the cosine to the top, move the cosine to the bottom, and cancel them out there. But just as easy to do it this way. So you're left with 3 times sine x divided by 1, which is 3 sine x. That is not your answer. That is just the simplified version of this. These are the same equation. Now, I can derive this. Derivative of sine is cosine. So this just becomes 3 cosine x. Right? So simplify, reduce, then solve. This one, just like we did before with the power rule, but you have the addition and subtraction. So you treat this as 3 individual problems and then you mush them back together. So this becomes negative 3 times 4x cubed plus 5 times 3x squared minus 18. Derivative of x is just 1. Negative 12x cubed plus 15x squared minus 18. Right? Easy stuff. Here, 10 times 5x to the 4th. Remember, you're subtracting 1. 7 times 3x squared, and the derivative of constant is 0. 50x to the 4th, 21x squared. Simple. All right, problem 11. 12, 13, 14. Ready? Let's go. 1/3 times 3x squared. Oh, sorry. I just rewrote this as 1/4. I just turned this to x to the -1. All right. You remember you can't have x's in the denominator yet. Soon you can, not you guys. So 1/3 derivative of x cubed is 3x squared, 5x to the 4th, and negative x to the -2, because -1 minus 1 is -2. 1/3 of 3 is 1. 3 times 5 is 15 over 10. That reduces to 3/2. And negative and a negative is a plus 1/4 x to the -2. If you want to make this x squared plus 3/2 x to the 4th plus 1 over 4x squared, that's acceptable as well. All right, I don't always have enough space to write everything, that's why. Number 12. We have to rewrite this. Now the square root of 9, square root of x. You have to square root each one of these. What's the square root of 9? 3. And then the square root of x equals x to the 1 over 2, because technically this is a 2 there. If there's nothing there, you just assume it's a base, it's a 2. So this becomes 3 x to the 1/2, because I'm taking the square root of 9, square root of 10, all right, plus 10 x to the 10. 3 x to the 1/2 plus 10x 10 stays there. All right. 1/2 minus 1 is -1/2, so this is 3 times 1/2 x to the 1/2 minus 1 plus 10 10x to the 9th. All right, this is 3/2 x to the -1/2, 100 x to the 9th. All right, also you could say 3 over 2 square root x plus 100 x to the 9th. Good. Rewrite this, x to the -4, x to the -1, -4, x to the -5, negative x, x to the -2. Derivative of 160 is 0. -84, x to the -5th plus 8x to the -2. If you want to rewrite it, -84 over x to the 5th plus 8 over x. Right. See? That's easy, right? Right here. I'm not giving it. I'll switch. Derivative of sine, cosine, derivative of cosine, negative sine. -10 cosine x plus 1/8 minus sine x. Right? And then you just do negative times 1/8 is negative 1/8. So it's -10 cosine x minus 1/8 sine x. Right? Look at that, halfway done. All right, nice and quick. All right. Next two, here we go, a little bit difficult. All right, first thing you want to do is you're going to want to expand the bottom. 3x, the whole quantity to the 4th power. That is the same as 3x times 3x times 3x times 3x. You don't have to write this out, but it does help a lot of students that don't see that I'm multiplying the 3 to the 4th as well. 3 times 3 is 9, 27, 81, x to the 4th. All right, now because this is x to the 4th in the denominator, I make it x to the -4th in the numerator. And now once I rewrite it, I solve. -4x to the -5th. Negative and a negative is a positive. 8 times 4 is 32. 32 over 81, x to the -5th. If you want to put the x to the -5th, put it back on the bottom and make it positive. Be my guest. All right, let's look at 16. Ugh. Rewrite it. X to the 1/2, x to the 1/4. All right. So negative x to the 1/2 plus 3x to the 1/4. 1/2 minus 1 is 1/2 minus 2 over 2. 1/4 minus 1 is 1/4 minus 4 over 4. All right. 1 minus 2, -1. 1 minus 4, -3. That's my answer. Notice this has nothing to do with this sign. All right. Also, if you want to make it -1 over 2 square root of x plus 3 over 4, the 4th root of x cubed, you can as well. All right. Rewrite, solve. Problem 17. Distribute. Don't forget to distribute. We don't know the product rule yet. That's next lesson. -10. Remember when you multiply exponents together, you add them. So you're going to take negative 5x cubed times this, negative 5x cubed times this. Negative 5 times 2 is negative 10. 3 plus 6 is 9. Negative 45 x to the 5th. Now that I distributed, that I solved it like that, now I can effectively derive. Negative 10 times 9x to the 8th minus 45 times 5x to the 4th. Negative 90 x to the 8th minus 225 x to the 4th. Right? Woo! Gonna work out here. When you have a denominator, because you guys do not know the quotient rule yet, you have to divide both of these by your denominator. 4x to the 5th divided by x cubed minus 8x divided by x cubed. For some reason, every year I teach this is a concept that is very difficult for a lot of students to understand. I don't know why really. It seems like it's fairly simple, but a lot of times they just forget. If there's just an x here by itself, it's not adding or subtracting by anything, you can divide anything in the numerator by it. Subtract 5, 3, so you have 2 more on top. 1, 3, you have 2 more on bottom. So it's 4x squared minus 8x squared. You can also say 1 minus 3 is x to the negative 2, and go right from here if you prefer to simplify exponents that way. I always like to put it in this form first personally, but easy to jump here. 5 minus 3 is 2, 1 minus 3 is negative 2. Alright, now, that is just the same version, same thing. Now you going to use your power rule. 2x, negative 2x to the negative 3. 8x minus 16, positive because 2 negatives make a positive, x to the negative 3. If you want, negative 3, move it to the denominator. Okay. Can't say I'm going too fast because you can always pause it. All right, from 19 to 20. That's the beauty of videos, isn't it? All right, so first step here is you don't you say distribute, because look at that. Remember PEMDAS, parentheses, exponents, multiplication, division, addition, subtraction, right? Exponent. You have to FOIL that piece first, because when you square this, you're multiplying by itself. It's not x to the 4th plus 9. It's all of this. A lot of people just square each one individually. Remember, you actually have to multiply the whole equation by itself. Now you FOIL. X to the 4th, 3x squared. 3x squared is 6x squared, 9. Now that you FOILed this part, you can distribute your negative 2. Negative 2x to the 4th minus 12x minus x squared minus 18. Now that you did that, now you are capable of your deriving. Notice a lot of this lesson is not the actual derivation itself, but simplifying equations so you can derive it, okay? A lot of algebra. Every time you ask when you're going to use algebra, this is why. Okay, it's not for really to do anything with besides be a building block for future maths. But no one ever wants to hear that. No one ever wants to prepare for the future. All right, so not no one, most no one, if that makes sense. Negative 2, 4x cubed minus 12, 2x to the first minus 0. Negative 8x cubed minus 24x. See? In the end, it's easy. Remember what to do with problem 20? Think back to problem 18. Correct. You divide everything by x to the 4th. So, 8 minus 4 is 4. 0, so this just becomes 7. And 1 minus 4 is 3. So you got 2x to the 4th minus 7 plus x to the negative 3. All right? Good. 4x cubed minus 0, derivative of a constant is 0, negative 3x to the negative 4. And that's it. 2 times 4 is 8x cubed minus 3x to the negative 4th. If you want to put the x to the 4th in the denominator, you weigh. Go at it. Have fun. Right? This is actually pretty easy. All right, let's go to 2 more. Oh, e to the x ln x. Remember the formulas? Derivative of e to the x is e to the x. Derivative of ln x is 1 over x. So this becomes, very simple, 6e to the x minus 4 times 1 over x. All right, nothing to it. Nothing very difficult, just plug and play. 60 to the x minus 4 over x. See? A lot of times when they look difficult, they're actually very easy. All right, 22. This one goes up a little bit. But we're almost done, so. After this, let me go to the word problems. Can you take anything out of the numerator and denominator? What number do you see you can take out of the numerator? What number does it look like you can take out of the denominator? So take a 5 out of the top, a 3 out of the bottom. X squared plus 2x plus 1, 3 times x plus 1. But that doesn't help us, does it? Well, maybe, can we factor that? I think we can factor it. Do you? Because right now, you cannot solve this. I could solve it, but you can't solve it. Sorry to brag. Why don't we factor this? Factors of this, factors of 1 that add up to 2, 1 and 1. So it's 5, x plus 1 times x plus 1 over 3, x plus 1. Now, another thing a lot of students mess up with. What exactly cancels out here? Okay, x plus 1 and x plus 1, but do both of these cancel out with this? No, because this is multiplication, you can only cancel one set out. Okay, it's just like if you had an x squared over x. I would still have an x on top. All right, so it's 5 x plus 1 over 3. 5/3 x plus 1. What can I do with this 5/3 now? Or you can just say 5x plus 1 over 3. It doesn't matter. I can distribute it, right? 5/3 x plus 5/3. If I did 5x plus 5 over 3, I would end up at this step anyway. What's the derivative of 5 over 3x? 5/3. What's the derivative of 5/3? 0. So my answer is 5/3. All of that for that. Hopefully you got it and you feel really good about yourself. All right, now let's get to the fun word problems. I think we got 2 left, 2 or 3. Woman throws a snowball off a ski lift, and its position is measured in feet and seconds with the following equation. S of t equals negative 6t squared plus 30t plus 84. How high is the snow lift when she throws off the ball? All right, so what is her original position? Well, that is when your time is 0. So when time is 0, that's how high she is originally, right? When she throws the ball. So when t is 0, I just plug in 0 for all the t's. S of 0 equals 0 plus 0 plus the only number without a t attached to it, which is 84 feet high. All right? That one almost everyone always gets. Next two, how long will it take the snowball to reach the ground? All right, so we discussed this earlier. When it reaches the ground, what do we know? T isn't 0, so we're looking for t. But what is 0? The position function is 0, because the ground is 0 feet high, right? When she throws the snowball, she's up here somewhere. She throws it, whoosh, all right? And then when it hits the ground, it's at 0. So 84 feet in the air, throws a snowball, boop, hits the ground at 0 feet. So I set it equal to 0. Now, once we set an equation equal to 0, we have to try to solve. So let's look at some things we could take out here. Is there any numbers that you could take out? Did you say 6? I always take out the negative though, because you really don't want a negative t squared in front. It's harder to actually solve. So if I take out negative 6 here, I'm left with t squared minus 5t. Make sure you change all the signs. Minus 14. Now I go, okay. Oh, please don't make me use the quadratic equation. That's the first thing you're thinking in your head. Second thing, is there any factors of 14 that when I subtract them from each other, they give me 5? So let me think of the factors of 14. 1 times 14, 7 times 2. That's it. So 1 times 14 is 13, no good. 7 times 2 is 5. That's good. Now since it's negative, I'm going to want these 7 to be negative, because negative 7 plus 2 is negative 5. So my answer is negative 6 times t minus 7 times t plus 2 equals 0. All right? Still good. Next step. Since I'm solving for t, I can just divide everything by negative 6. 0 divided by negative 6 is 0. Just pretty much goes away, because we only care when these two things equal 0, because that makes the equation equal 0. So when t minus 7 equals 0 and when t plus 2 equals 0, that is when our snowball can reach the ground. Add 7 to both sides, subtract 2 from both sides, you get 7 or negative 2. So what do you think it takes? 7 seconds or negative 2 seconds? Not negative 2 seconds. It takes 7. Why not negative 2? Because you can't have a negative time, right? Obviously. So it takes 7 seconds for it to reach the ground. How fast is it going when it hits the ground? All right, so do you remember how to go from position to velocity? Think the velocity is the blank of the position function. That's my position function. How do I find v of t? Derive it. So velocity is the derivative of your position function. So when I derive this, negative 6 times 2t plus 30 plus 0, the derivative is actually negative 12t plus 30. 2t times negative 6 is negative 12. 30 times 1 is 30. 0. Now that gives me the velocity function. Now how do I know how fast it is when it hits the ground? Because when it hits the ground, it's going how long does it take to hit the ground? 7 seconds. So I just take my 7 and plug it in for t. Negative 12 times 7 plus 30. Negative 84 plus 30 is negative 54. And that is in feet per second. Now, why is it negative? Because the snowball is going down. Okay, so it's actually going 54 feet per second. If you want to put the negative almost like as a vector to show that it's going down, that's fine. If you didn't put the negative, technically you're right when you're saying it's going 54 feet per second. Right? Got it? Can we handle another one? Let's go back. I always like sometimes to go back to where we started. This is the first problem we did. So it's going to be the second to last problem we did. What's my f of x? Let's see if you remember. 2x squared plus 4. X plus delta x goes in for my x, right? So 2, x plus delta x squared plus 4, x plus delta x. I have to FOIL this. Anytime you FOIL this, look at it, it's always the same. X squared plus 2x delta x plus delta x squared. So it's 2 times this stuff plus 4x plus 4 delta x. Well, I should say an x. I don't know why it says a c. Interesting. Must have changed it from a different problem. All right, anyway. Nothing there we combined anyway. Remember, this is an x. So you got 2x squared, distribute the 2, plus 4x delta x, plus 2 delta x squared, plus 4x, plus 4 delta x. So I cleaned it up there. All right. This minus this over this. All right. I'm not going to say it all because there's a lot of words. These always cancel out, so look for the 2 delta x squared. 2x squared. Ugh. Look for 4x. Okay, so you're left the middle. 4x delta x plus 2 delta x squared plus 4 delta x over delta x. Notice you have delta x's in all of them, so you can reduce them. If you didn't, you probably messed up somewhere. Take 1 out. Take 1, you're left with 1. Take the 1 out. Take the 1 out. 4x times 1 plus 2 delta x plus 4 times 1 over 1 gives you 4x plus 2 delta x plus 4. Now we're going to plug in 0 for delta x. You get 4 times 2 times 0 plus 4. Sorry, 4x. 4x plus 4. So this is my tangent line. How do we find the slope? What number are we going to plug in here? Pick one. The x. We're going to plug in the negative 4. 4 times negative 4 is negative 16 plus 4 is negative 12. So the tangent line, the tangent slope at that point. Let me back at it. All right. Bring it all back around. See? All right. Let's go back. Last question of the day. Man throws a baseball now. Girl likes to throw a snowball. Man throws a baseball off a rooftop. Not a smart idea. You could hurt someone. And his position is measured by feet and seconds with the following equation. A. How high is the, not mountain, rooftop? How high is the rooftop? I gotta clean this whole problem up. So how high is the rooftop? How long will it take the ball to hit the ground? And how fast is the ball going when it hits the ground? So it's not a mountain, it's a rooftop. As you can see, I just pretty much changed my last question. So first thing, how high is it? We set t equal to 0. So the rooftop is 124 feet high. Oh, this must have been based on when the guy threw the bike off the mountain. All right, so 124 feet high in the air. How long will it take the ball to hit the ground? Let's see. What do? We set. Good. S of t equals to 0. That's why I put the other problem in between, to make sure you guys just didn't copy word for word what I did. So 0 equals negative 4t minus 40t plus 124. All right. What can we take out of this equation? We can take a negative 4 out. You're left with t squared plus 10t minus 31. Ready for the fun to begin. Factors of negative 31 are 1 and 31. And that's it. 31 minus 1 does not equal 10. Uh-oh. So what does that mean? What do we have to do to solve for this equation? We can first divide everything by negative 4, keeping with this. Now how do I solve here for t? Yep, you're right. Quadratic equation. So you can't factor it, so you would have to use the quadratic equation. A is 1, B is 10, C is negative 31, and the equation is negative b plus or minus the square root of b squared minus 4ac, all divided by 2a. Negative 10 plus or minus the square root of 10 squared minus 4 times 1 times negative 31. Make sure you carry the negative sign. All right, now, when solving this, just don't plug them into the calculator all at once, or else it most likely will mess up your answer. Negative 10 plus or minus 100 plus 124 divided by 2. 224. Negative 10 square root of 224 is about 15.0. I just went to 3 significant figures. Divided by 2. It's not exactly 215. That'd be 225. So it's like 14.99, something like that. 98. So I just rounded up. Anyway, negative 10 plus 15 divided by 2. And you have negative 10 minus 15 divided by 2. All right, that's what this means. So our two answers are going to be 2.5 and negative 12.5. So, which, these are switched. This should be negative 12.5, this should be 2.5. Doesn't matter. All right, so which one of these two is good? The 2.5, because you can't have a negative time. Going, 2.5. Second still hits the ground. That's pretty quick. How fast is it going? So you have your original position equation. To find the velocity equation, what do? You derive it. Negative 8t minus 40 plus 0. Because this is negative 4 times 2t minus 40 times 1 plus 0. All right, now I'm going to take my t, which is 2.5, and plug it in here. Negative 8 times 2.5 plus 40 is negative, what's that, 16, negative 20 plus 40 is negative 60. Don't forget units, 8%. All right. We good? Yeah. Awesome. All right. Quick recap. Derivative constant, 0. Power rule. Power x to the power minus 1. Constant multiple rule, whatever constant's in front of your function, derive the actual function and then multiply by your constant. And sum or difference, if you have addition or subtraction things, just derive each one individually and then add or subtract in the end. Okay, I'll give you these formulas if you need them, or you have them on your own. And I believe that is that. So that concludes the review of 3.1 to 3.2. By now you guys should be pretty much experts at the basic derivation of equations, finding tangent lines, finding tangent slopes, right? And even doing a little bit of physics. So good luck on your test. I know you won't need it. And to the next lesson, we're just going to keep on expanding. All right. So have a good day.